Is the stream coming fine?
Yes.
Okay, fine. I'll share it here. Okay, I think it is fine. So, just a quick recap about what we were trying to do in the previous class, right? So, let's go to Python 3 and grade to GPA. Okay, so this is what we were working on. So, we were working on this grade to GPA, right? So, what we have learned is a new thing called SIP, okay, and we have also learned a new thing called Pepite standards. So we have looked at how to write the code as per the Pepite standards, and we discussed the Pepite standards also in the previous class. Okay, and today we will be going to the next topic. So we also finished files, correct? So we finished files, and files were we learned this grades to GPA. We wrote this program when we were learning files. Okay, so in this particular program we are reading from the file and we are computing something for each row or each entry. So that's what we are doing in this particular program. And then we learned about this Pepite standards, and that is how we wrote this program slightly differently. So if you look at this particular two lines which I have highlighted right now, those were the lines that we had in our program earlier. Okay, and we have changed it to something else. Instead of enumerate, we have used SIP, where we have two lists, credits and grades, and SIP is going to give a combination of these, the first two items together and then the second two items together. So it will pick the first item from the credits and it will take the first item from grades, SIP it together, and it will work only if credits and grades are of equal length. If credits and grades are of two different sizes, right, then SIP cannot work. So credits and grades in this particular example are the same size. 6 credits are there and 6 grades are there, right? So we will have a total of two lists which has 6 elements each, and one is called credits and another one is called grades, and we then combine it together, and then we do for credit comma grade in SIP credits comma grades. And then we have, earlier we were using I and val etc, right? So if you look at the last to last lecture, you would see that in the commented for loop itself we had used something else, like for I comma val in enumerate grades. Okay, so that was also not making any sense, because if I look at the program, right, I wouldn't understand what does I mean or what does val mean. But when I changed it to grade, right, it has become more readable. And this is very important, that you use meaningful variables. Okay, this is very important, and you use meaningful variables. So this is something that you have to consider in the Pepite consideration itself. Okay, and another thing that I have mentioned over here is NumPy can also be explored. Okay, but then there is a slight problem over here, right? We need to get this grade point. So it's not the grade that we want, but it is the grade point that we want. Okay, so if we can generate the grade points, okay, or the grade okay, I would say individual GPs, grade points, okay, or grade points. So this is a snake case that I have used, where if you guys do not remember, camel case and snake case are there. That is as per the Pepite convention, and I mean, this is something that is followed universally around the world for all the different programming languages that you can imagine. Okay, and for different programming languages they would use different conventions. So here there is an example for a camel case and a snake case, and the variables are usually named in snake case, meaning that if there are multiple words in the variable name, then those are actually separated by a underscore. So that's what you call as the snake case. And in the camel case, if you look at that, you can see that it is the first letter that is capitalized in the word. At the first letter of the first word is small. So the first C, right, is small, but the second C in case is actually in caps. Okay, so here, right, we will have to do a list comprehension. So it has to be something like for grade in grades, okay, and then I can do grade point of grades, grade, yeah. So that is going to give me the individual grade points in one list. Okay, so let's try to just okay, I've just saved it here, and I'm going to the terminal. Okay, so I hope you guys know how to take the terminal and how to take the, just a second, yeah, the interpreter. So I'm taking the IPython 3 interpreter. Okay, and over here we have the grade to GPA, but then this is not, we have started the IPython interpreter from the /home/Anoop. So we should be going to Python 3 folder. Okay, and because the grade to GPA file is there, and the grade to GPA data is also there. Okay, so we will do we will now, if we start IPython 3 from here, right, and we type pwd from the IPython IPython interpreter, we will see that our workspace is home Anoop Python 3, and we have the these files and every details in the particular folder. Even the fib.py, the module that we had written as part of our when we were learning Python, right, we had put it in this directory. Okay, so right now the Python 3 we are there, and %run -i grade to GPA. I ran it. The reason why I ran it is, and I have run it in interactive mode with the -i switch, and with the -i switch, right, these variables get imported. These variables within the program get imported into the IPython namespace. So I look at individual grade points. There are 6 grades, and that will be related to Sam, because that is the last entry. Okay, and now we are trying to explore NumPy for this particular operation. So we want to see how fast we can make it. But then what you need to understand over here is, we have a list comprehension here, which is the generating the individual grade points, so which is actually a loop. Okay, and with NumPy, what we are going to do is, we are going to avoid this loop as well. We can actually avoid this loop. So until we implement it, I don't want to remove it. So let me keep it there. Now NumPy, right, unlike our list, is a slightly different kind of arrays. So you have learned arrays in CS101, and in CS101 in introduction to computer programming, we learned that in C programming language, an array contains the elements of the same type. But in a Python list, when we learned that the Python list is, can hold a collection of items, and the items can be of different data types. It can also include another list in there. It can have a list of lister also in there. It can have any kind of data items in there in the list. But in a NumPy array, it can have only one data type. So let's try to import NumPy, and I'm going to do it as import NumPy as np. Okay, so I will call it as np in my program. Instead of fib.fib, I'll call it as np.py. sum or np.array. So I'll try np.asArray. Okay, so there is a function called asArray that can actually convert an existing list into an array. So let's try to give the individual grade points as an array, and I'm not actually, you know, I'm not having anything on the left hand side. You can see that there is no right hand side and left hand side for this line number 5 that I am trying to put in here. I just have the function call. So whatever will be returned, right, will be returned and displayed into the terminal, I mean in the interpreter. So I'm just trying np.asArray individual grade points, and you can see that it has created something of an array. Okay, and but I have not actually saved it somewhere, right? So let me save it somewhere. So individual grade points. So we know that in Python you can actually have one variable pointing to a string type at first during the runtime, and during the same runtime itself that variable can, in case, you know, if you want, you can point it to a value, some other value other than a string. Okay, or it can be a complex number. It can change the data type in between during the runtime is what we know. So we know that the individual grade points is actually a list at first in line number 3, and in line number 5 we have just passed individual grade points, and in line number 6 we are actually passing the individual grade points to the np.asArray, and we are taking the return also into the same data type. Oh, let me not into the same variable, but let me not do that for the time being, because I want to show you the differences. Okay, so individual grade points array. So I've just saved it here, individual grade points array, and if we look at that dot d type, okay, it says that the data type is int64, which means that it is 64-bit integers that is actually stored in here. That is fair. Okay, now next is credits. So I can do np dot, or I can also do, I think, np dot array. Oh, can I do that? Yeah, let me see what is np dot array. Object data type. Yeah, I can actually give the object also. So instead of as array, I can use this function also, np dot array. Then I can give the credits. So that's what I want to pass it next. So credits, and d type, I don't need to specify that, so let me not specify that. Let's see what happens. Okay, so credits np array, I'm just making it more, what do you call, more obvious. Okay, we are actually looking at the credits numpy array. So we have credits numpy array, then credits np array dot d type. We see that that is also an int 64. So individual grade points array, okay, and credits np array, right? We can do something like individual grade points array into credits np array, and that is going to do the multiplication, as you can see, right? So the individual grade point array was 989898, and this credits array was 433233. So now it is 9 into 4 36, 8 into 3 24, 9 into 3 27, 8 into 2 16, 9 into 3 27, and 8 into 3 24, correct? And you can see that I can do an np.sum. Okay, so I am using the numpy sum itself, okay, divided by, I can do len of credits of np array, and that is going to give me I think the division has to be again sum of the credits, correct? So it has to be np.sum of the credits, and that becomes 8.555, which is exactly the same GPA that we have calculated for SAM. So essentially now I am going to replace the lines of code in the for credit, I mean from this for loop, right? Earlier we had this for loop which we discarded for this SIP thing, okay, and but then, you know, this SIP thing was over here, and now we are going to discard this thing also. I mean, I'm just trying to show you that there are different ways to write your program, and this is perhaps very interesting, right? You have different functions, and all you are really interested in actually how the data gets manipulated over the period of time. Okay, so we are actually looking at how to explore numpy for this particular option. Okay, so in this particular case, we are actually exploring the numpy, and I need a few things. So percentage hist minus n, and I am going to copy this line. Okay, and I'm going to call it as points only. Okay, not as an array. I'm just going to replace it, and then next is I need credits. Copy. So the credits, you can see that is created only once. So let's and since it is it's created only once, right? We can actually create the credits array outside the loop. And what is the advantage of doing it so outside the loop? Because if we do it outside the loop, it will run only once. If we do it inside the loop, it will run that many times, how many times ever the loop runs. So as to avoid the number of computations, if you do not have any reason to keep something inside the loop, do not keep it. Correct?
Yes.
Right. So here we have the individual grade points. Okay. So right, I don't have to split this whole thing into two different lines. I can actually do it in one single line. Hopefully I hope you won't get confused. Okay, so I've just commented it so that you have an idea what I have done. Okay, so earlier the list comprehension, the output of the list comprehension is passed as a parameter to the np.as array. Okay, now I have the credits numpy array and the individual grade points, right? So this SGPA will become np.sum credits numpy array, correct? So it's called credits numpy array. I have not, or wait, we don't have any reason to keep the credits as a list, right? We don't have any reason for that. So let's do the np.array here itself. Okay, and remove this. So it's called credits. It's not going to be called as credits numpy array because it's a numpy array. Okay, and we don't have the sum of product here because now it's going to be just individual grade points into credits, right? And we can do an np.sum over here, np.sum, save it. You can see that we have actually gotten rid of so many things here, right? One loop we got rid of completely. Okay, and that is why numpy makes it faster. So let's try to run the program and see whether the program is.
We did import numpy as np, sir, in the script.
Yes, that's thank you. So yes, it has to be import. So we can actually delete this import numpy, or let's just keep it there. Import numpy as np. Yeah. So Abhishek mentioned to us that sir, we have not done that, right? Let's see what happens if we go ahead and try to run this program in the IPython terminal, right? It will run. Do you know why it would run? In the IPython terminal it ran, and when I take the IPython when I take the shell and let's say python cd python 3, okay, and I am trying to run the python 3 grade 2 GPA from here, right? It will give me an error. It will say that np is not defined. While I can do one thing, del np here. I'll do a del np in the IPython terminal because this I have already done the import numpy as np in the IPython interpreter. That is the reason why it ran this time. The next time if I do a del np and run it, right, it will not run, it will give me an error. Np is not defined. So I have to have the line import numpy as np, and that's the module that I am going to import. Okay, and you can see that we have now changed this program into this, and now you can probably understand that the computations that are happening in numpy are in place and parallel, correct? So let's try to run this now. Yes, it ran. Let's try to run it from here. Yes, it ran. Okay, and we have replaced it with the numpy module. If you have any questions, doubts, please ask me that now. Just a second, guys. I'm getting a call. Okay. Just a second. Okay. So, do you have any doubts regarding what we have done here?
No, sir.
Okay.
Sir, is there any way of having a reverse dictionary like in the usual dictionary the key identifies the value, but is there any way such that the value identifies the key?
Who asked me this question?
Sir, Bhadraksh.
Okay, Bhadraksh. So, what kind of mapping do we have in dictionary?
Key to value.
Okay, what is that? Is it a many to many or a one to many? Or a one to one?
One to many.
It can
One
be
to
a
many,
one to
one to
many.
one.
It can be a one to one and a one to many. It is
Yes.
always not a one to one. If it was a one to one mapping, you could have done a reverse mapping.
Yes, sir, correct.
Otherwise, you cannot do.
But how can we do that, sir?
If it is a one to one mapping, meaning that the second one is also unique, right? Which means that the second part can be used as a key.
Okay. So
Okay.
like in our stuff, no sir, like S was appointed 10, there was no other breakpoint which had 10.
Huh.
From
Okay.
there, how can we access S by giving 10 or 9 by giving A?
You cannot do it that way directly. You will have to create a reverse dictionary.
Achha, another dictionary.
Yes, and I can actually give you as a program if you want. Got it,
Okay,
right?
sir. So, yes, sir.
Right.
So like that I know, but I wanted to ask if there's any efficient way. Like here we are creating another dictionary. From
No,
the same
I
dictionary could
don't
be.
think there. I mean, at least I have not come across that so far. So
Oh, okay, sir.
if I come across that, I'll definitely let you know. Right now, I do not know.
Okay, sir.
Okay. So now shall we go to the next topic? So we want to learn about something called exceptions. So let me start by showing you something like x is equal to 1 divided by 0. Would this work? Are you guys able to see my screen? Let me clear it.
Yes, sir.
Okay, so I'm going to type x is equal to 1 divided by 0. Any number to be divided by 0,
Not defined, sir.
it is not defined, right? It will be an error. So, and if we tried that, right, it will say that 0 division error, division by 0. So there is an error that has actually happened over here, which is when we try to run the program, or when we try to run this particular line. So let me try this particular thing over here in this particular code itself, which is I'm just going to do x is equal to 1 divided by 0. We have no particular use for x, but I'm just going to include that in the grade to GPA program, and I have done it in the loop. So let's try whether it's going to do something into the program or not. We try to run the program and we can see that it has mentioned in line number 20 x is equal to 1 by 0, 0 division error, and it has also mentioned the two lines before that and the two lines after that particular error occurred, and you can see that it has not actually produced any results. Let's see whether it will produce any results from the terminal if we try to run it. No, it actually had the same problem. Okay, it said that in line number 20 we have a 0 division error, and because of this 0 division error we cannot proceed further. Correct? So this is what you call as an exception. Okay, so exception means that some operation cannot be performed because either it is undefined or it will cause some issues. So this is what you call as an exception. So Python language and every programming language, even in C programming language, we had this division by 0 problem. So there also we have something called exception. Okay, so the exception means that what you can see over here is that when this exception happened in this program, right, in the grade to GPA, the program did not produce the output. So what do you understand? When the exception happened, the program did not produce output. The program quit in between when the exception happened, and it could not proceed further because the program crashed when that exception happened. And with exceptions, what we want to see is we should be able to handle the exceptions rather than letting the interpreter crash. So if you put the exception statements, if you put the statements which could cause exceptions in your program and you do not do anything to handle those exceptions, then the program can crash. Okay, and it will not produce the results. So that is a problem. So we want to learn and understand what are exceptions, and we want to actually handle the exceptions by ourselves so that our programs do not necessarily crash. Just a second, guys. I think that is 11 exceptions. Just a second. Okay. Because it was compiled only once with the make, and because of that issue it was not giving the out of page numbers. It was showing earlier 1 out of 1, and now it is showing 1 out of 20 pages. So the question is, how do you signal errors to a user? Okay, so we want to actually not do the division by 0, or if the division by 0 occurs, then we want to actually handle it rather than letting the interpreter die or letting the interpreter crash. Okay, so we want to actually signal the errors to the user. So you can actually notify the errors using the Python space. So there are several standard exceptions like syntax error, input output error. Okay, so syntax error, IO error, etc. Users can also raise errors. Okay, so this exception mechanism, right? Let me show you something. Throw and catch example illustrations. Okay. We came across a very I searched for things especially related to computer science, but unfortunately I got something because throw and catch is a very simple ball game, right? But I think the first link that is over here, which is regarding the throw and catch, and that's regarding the exception handling. Okay, let's just see whether it's going to give us any important information. I mean, whether that would be enough, not enough. let me add a keyword exception also here and go to images, right. Okay, so right, so this would how the exceptions be handled usually by a programmer. Okay, so that's like the problem occurs, and during the problem when it is happening, right, you create an exception, you throw the exception and you handle the exception. So it can be like, you should think of it like this. There is a try block. This is for C or C++ exception handling. Okay, so there's a try block, which is where this cartoon character is standing. I don't know who this cartoon character is. So there's this try block, and then there is a catch block. Okay, so in the try block is where the computation is tried. Okay, and when a particular exception can occur, right, that particular exception is raised from here. Okay, it is raised as in it is mentioned to have occurred at this block. And now what happens is that this catch block has to get the exception that has occurred and do something to handle the exception. So in this particular example, we have done something like a pass or do nothing, right? There's nothing that they have written over here. So in this one, they don't do anything, but ideally you should be able to throw an exception. Okay, and the catch block has to catch the exception and handle it. So that is what we would mean by this. Problem occurs, create the exception, throw the exception and handle the exception. Okay, so this is an example for how the exceptions can cause problem in a running program. So here, right, there is an example of a car which is running, and in between an exception happened and the car stopped, which is not right. Okay, which could be maybe the car ran out of fuel or ran out of battery charge or something like that. So in this particular third block, we have an exception handling, so where the exception is handled. Okay, so that is what you call as the exception handling, which would actually not cause our car to stop indefinitely, but once the exception is handled, the car will be able to run again, or in our terms, when we try to understand, it is the program that will be running again. Okay, so that's the idea of exception. So let's try to see what it is. So I told you that users, the exceptions are created. So once the exception happens, right, users can also raise errors. Users can create their own exceptions, and exceptions can be caught via what? A try except block. So it's something like this. A try, and over here it is called catch, but here it's called an except block. Try except block. And so let's try. While true, print hello world. Okay, this is a line that we have written, but you can see that in the while loop, right, you need to actually have a semicolon, a colon after the while true, and the print hello world will be a statement inside the while true loop. But unfortunately, this has been written as one single line, and this would actually result in a syntax error. Okay, so this is an exception. So let's try that in our program itself. So let's try. I'm just going to comment it, and over here while true, print hello world. So this is the program that we have, correct? Nothing else. And we try to run the program. We try to run the program. It will give us a syntax error saying that invalid syntax, correct? So that's an exception. Now next is, let's try this in our program itself. So I'm going to remove this, or let me keep this. So this is a zero division exception, correct? Okay, and this is a syntax, what is it, syntax error, and earlier it was a zero division error. Okay, and now we can try something which is print spam. So we know that we have not defined a variable called spam in our grade 2 GPA program, correct? We don't have a variable called spam, so we are just trying to include that. And when we run it, right, it says that there is a name error saying that such a thing has not been defined. So this would result in a name error, right? Okay, so these are the different exceptions that are over here: name error, division by zero error, syntax error. Okay, so this is a zero division error. Okay, so this is an integer division or modulo by zero error. Next is when we try, let's say, the IPython. So 1 plus 1 plus 1. Okay, so here, right, if I had done 1 plus 1 like this, it would have given me 11 because it results in a string concatenation. But if I do try addition of a string and an addition of an integer, it will give me an error, right? It will give me a type error saying that you cannot concatenate one string and an integer, can concatenate string, not integer to string. Okay, so that gives you a type error, cannot concatenate string and integer. Okay, so next let's try to look at this particular program, this code. Okay, this 3 lines of code, what does it do? So prompt is equal to enter a number and q to quit, a is equal to input of prompt, and num is equal to int of a if a not equal to q, else 0. Okay, which means that if the value of a is q, then you will return 0 to num. Otherwise, the value of a will be int of a, whatever you have entered there. What if the user enters some other alphabet other than capital Q? So that is also possible, right? So the user can enter a or b, and we know that if I do int of a, right, that will give me an error. So invalid literal for int with base 10, and that the error is a value error, correct, right? So earlier when I tried 1 plus 1, that is string 1 plus integer 1, that gave me a type error. Now it's throwing me a value error. Okay, so this is an example for the problem that can occur in a program when the program runs. So when the user enters some value to a which is not q but some other alphabet, then it enters into an error. So the thing here is we have to handle the exceptions in Python. Okay, so this is an example for the try except clause. Okay, so here, right, the in C++ this except part is called the catch, and this, so we have the try catch block, or here it's the try except block. So Python provides a try except clause, and here let's try the question. Prompt is equal to enter a number q to quit, a is equal to input of prompt. Okay, and try num is equal to int of a, print num. So whatever exception that happens will happen over here. Okay, will happen over here, meaning that it will raise an error if the value is any value other than a number. Okay, if you enter q, it will raise an error. If you enter a, it will raise an error. If you enter any other value, it will raise a value error. So here we have the exception part, and the exception part is what will handle this exceptions that is created in the try block. Okay, so if an exception is raised in the try block, a value error is raised in the try block, it will soon go into the except block, and in the except block we have a question: if a equal to q, so if q is entered, right, then the that's a valid input, and what you need to do is exit from the program, otherwise you will print a wrong input. So this kind of says that instead of throwing a value error at the user and stopping the program execution completely, here we are trying to handle the exception, correct? So we have an exception that has happened and we are handling the exception. So here, right, in this exception we are taking any exception that happens. So we do not know what kind of exception it is. Is it a value exception? Is it a syntax error? Or is it a zero division error? Is it a type error? We are not looking into any of those things. We are not classifying it accordingly in this particular example that you see on the slide number 9. Now if you go into the slide number 10, here we are specifying the exception type also. Okay, so we can use specific exceptions, avoid blanket exception clauses. So in this particular slide number 9, this except clause, this except colon will except for any exception that has created, but, and meaning that, you know, even if an error happens which is not the value error, your except clause will start working. Okay, and that is called, like, it will catch any error that can occur. So we want to actually specify the kind of error that we want to handle in this particular block, in the except block. So we can see except value error, you can actually enter the type of the exception there. So which means that this exception block will execute only if the try block raises a value error. I used raise, R-A-I-S-E. Okay, so let me show you that. So we have, so this is a try block where exceptions can be raised or happen. Okay, and then except block where exceptions are handled. Okay, so this is what you need to understand. So in the try block is where the exceptions are raised, where the exceptions occur, and in the except block is where the write the routine to handle the exception. Okay, so here is an example. In the slide number 9 we have the exception, that's a blanket exception which will work for any exception. And in the slide number 10, the only difference is that we have used a specific exception which is a value error. So except value error colon, and then we will do if a equal to q, print exiting, else print wrong input. Okay, so right, so let's try to, you know, write this program and see what happens. So I am going to create a new file. So before that, let me put it here. Okay, and this one over here. So we have the program and the editor over here. So let me create a new program, xw, and it's an exception example1.py. okay, prompt is equal to enter a number for q to quit. Okay, so that's fine. While true, try. So we have the try block where x is equal to int of input prompt break. So we have to break from the try block once except value error, okay, and print invalid input, try again. Okay, so right now we are actually not looking whether the user has entered Q or anything, but okay, let me remove this Q or Q to quit as well, because as per the problem statement that we are looking at this particular example, in this one we are actually not handling any values other than a number. Okay, so we are handling only numbers here. So let's take the terminal, and percentage run minus I exception. Okay, enter a number, and I'm going to enter A. It says invalid input, try again, and I enter 1. It worked. So this one will keep on working till I take an input of a number. Say I type T, T, Y, S, G, H. It doesn't work. I enter a number and it takes the number and quits. So X has the value 6. Okay, so this is what you should understand by an exception. And how was this possible? So if I do not have this loop, right, this exception would be only, I mean, this statement would only run once. Oh, I cannot keep a break here because there's no loop, correct? So I run the thing, I enter T, it says invalid input and try again, but it doesn't give me an option to try it again. So that is where you have the loop and the break statement out of the loop. I hope this is clear.
Yes, sir.
Okay, so that is an exception example. Now we can have in this one, right, the user has to enter two values. Okay, so while true, try data is equal to input, x is equal to int of data dot split 1. So the user has entered a comma separated value. So user has to enter something like a comma 1 or a comma 2. Okay, and the second value has to be an integer value. So that is what it means. There are two exceptions that are given here. One is index error, input at least two values. So one is if I try data dot split and I do not have a comma in my entered string, right, then the data dot split cannot work. And because it cannot split it, right, and I try to take the second element, it will give me an index error. Next is if I try to do a data dot split comma and 1, that works, let's say that works, but then value is a character value, not a number, then the conversion will raise a value error and will give you invalid input, try again. Okay, so let's stop the exceptions for today. Let's continue with the exceptions tomorrow. Okay, so I hope you are able to understand and appreciate what exactly exceptions are. So exceptions are like, you have a perfectly running car which is running, but unfortunately because you forgot to fill the fuel, or you forgot to have an additional can of fuel with you, and when the car stopped running all in between, right, now you had to actually go down, get the fuel or make the changes so that the car will run continuously. If you had actually have been a little bit more cautious, you could have actually a priori, as in you could have actually handled this problem well in advance. You could have actually stopped at some fuel station where and refueled before the fuel was going very low. I mean, that's just an example. Okay, so the idea is that in computation you could actually cause any error to occur, and if you do not handle it, then it can cause the program to crash. So at line number in slide number 12 we will stop here. Is there any question? Do you guys understand exceptions clearly until here? And what
Yes,
about the
sir.
topics that you have covered so far? Do you guys all understand up till here clearly?
Yes, sir.
Yes, sir.
All right, sure. Thank you guys. So let's stop the class here. My goodness, this is what happens with YouTube. Okay, I'll do it slowly. So thank you guys. I think I have to take the attendance also. Just a second. Don't leave. I'll take the attendance. I and Guru Ishwar left the meeting, and there were around 30 students present. Okay, I and Guru Ishwar is still here. CS151 attendance. Oh, have I not given the time for Monday at session? From 10 to 11. Multiple sessions, repeat this session. I think 15th July. Add, and yes, we have the oh, did you guys mark the attendance by yourself today? No, this is for 11th. How can this be possible? Oh, okay, that's wrong. Okay, my bad. This is that was for the earlier class, my mistake. So today is 9th May. Yeah, students, please tell your attendance when you see your name.
Sir, Abhishek present, sir.
Abhishek, Ayan Guru Ishwar,
Aditya.
Aditya, Afrit, Akash.
Yes, sir.
Okay, Sanjana has left. Anshika, Bhadrash,
Yes, sir.
Bhupesh, Galanki.
Present, sir. Rupesh.
Yeah.
Charan present, sir.
Charan,
Sir, 13 present, sir.
13,
Sir, 14 present, sir.
14. Harshit,
Rituraj, sir, he was also present.
yeah. Harshit Kumar,
Sir, 15 present, sir.
15.
Sir, 17 present.
17. 16,
18 present, sir.
16%. 18,
18.
Sir, 19 present, sir.
18, 19,
20 present, sir.
20, 21,
21.
22. Yeah.
26 present.
26,
23 present, sir.
23%.
27 present.
22 present.
22, thank you. 24, 25,
28 present.
28%.
29 present, sir.
Thank you. 30,
30 present, sir.
31, 32, 33, 34,
33 present, sir.
35 present.
35,
36 present, sir.
yeah. 37,
34, sir.
34. Okay, so I'll mark the absentees now. So the
11 is present.
11 is present. Okay, sure. Harshit, I've marked present. Thank you. So Alluri Sanjana Rao, then Nikhil Upadhyay, Pankaj Trivedi, S. Rishik Nair, Sheikh Bashir Ahmad are absent. Is that okay? Correct? I think so. Okay. If there is any change, please do let me know through your class representative. Thank you, students. I'm leaving. Thank you.
Okay,
Thank you, sir.
Thank you, sir.
Thank you.